Hey guys, hope everybody's doing okay. What we're going to do right now is take a look at combustion reactions. Most of your combustion reactions fall into the standard traditional category of combustion reactions, but there are a few tricky combustion reactions that I want to talk about and show you where to find some solutions to those. So if you look at the screen, we have C18H38 plus O2, and this definitely falls into our category of traditional combustion reaction. So we have C18H38, that's our hydrocarbon. Hydrocarbon plus O2 is your traditional variety, and the products are always the same. So it's really easy to write the products for these if it's a traditional standard combustion reaction. So one of the products is carbon, so that's CO2. The other product is water, is H2O. So let's go through and balance this. So I talked about it before when I introduced combustion reactions a few lessons ago, and you should always start with your carbon and then proceed to hydrogen and then to oxygen. General rule is to save oxygen for last if you could, even if it's not a combustion reaction. The reason why that's true is because oxygen is found in 3 of the 4 pieces of this chemical reaction. So it's a little bit harder to figure out which one you want to manipulate when you're trying to balance it. So let's do carbons first. We have 18 on the left. I need 18 on the right, so that's easy. Now I have 38 hydrogens on the reactant side. I need 38 on the product side. But I do have an H2O here, so since I already have 2 hydrogens, I only want to put a 19 here. Because 19 times 2 is 38. Now I want to figure out my oxygen. So let's go through and knock it out. Here I have 18 CO2. That gives me, in this section right here, 36 oxygens. And then I have 19 H2O. 19 oxygens there. Gives us a total of 55. Okay. So it might look a little weird right now. You're like, okay, great. I need 55 oxygens on the product side. Well, I have that many on the product side. I need 55 on the reactant side. What times 2 will give me 55? Well, I'm not quite sure. So it's no nice number that's going to give me that because 55 is an odd number. Anything times 2 is giving you an even number. So let's actually write a fraction in where oxygen is. Okay, let's see what we would do here. Let's do 55 halves. 55 over 2. All right. Well, we all know 55 over 2 times 2 is 55. All right. So 55 halves could be what we put in front of oxygen. I wouldn't leave it like that. Okay. But what I would do then is multiply everything through by 2 because 55 halves doesn't quite look like it's supposed to. We need to have a whole number there. So instead of 55 halves, let's multiply everything through by 2. I did have a coefficient of 1 here, so that would have balanced it. I could have 1, 55 over 2, 18, 19. But I can't leave the 55 over 2 there. So let's multiply everything by 2. So instead of a 1, 1 times 2 is 2. Instead of 55 over 2, 55 over 2 times 2 is just 55. Okay. All right. 18 times 2. Oops, lost a carbon. 18 times 2 is 36. 19 times 2 is 38. Okay, so there you go. It's balanced. 2, 55, 36, 38. Sometimes they're not always this drastic. Okay, but you know, 55 over 2, or obviously that's 27.5. You could have had 27.5 written there. 55 over 2 makes you uncomfortable. 27.5 times 2 is still 55. All right, so you couldn't have it as 1, 27.5, 18, and 19. Right, just clear it out. So a couple of them that are like that, it's a little helpful strategy for. All right, you don't have to do that all the time, but it is there when you need it. Now the next one's a little bit weird. You have carbon disulfide is burned in excess oxygen. And if you look at your blue cheat sheet, actually, a part of it that we haven't really addressed yet is the very bottom where it says combustion reactions. This is our overflow for combustion reactions. Anything that's not a traditional standard combustion reaction will be found on the bottom of the blue cheat sheet. So we have 4 main types. It even says number 1 is your typical, and it says that you should know that, which we did from the first example here. But carbon disulfide burned in excess oxygen falls into another combustion category. If you look at your blue cheat sheet and you look down at the combustion section, carbon is a nonmetal, and a disulfide, you know, it's sulfur. All right, so you have a nonmetallic sulfide. All right, let's write the formula for this. Carbon disulfide, CS2. burned in excess oxygen produces what? If you look at your cheat sheet, this is going to be a combustion reaction number 3. Okay, combustion reaction number 3 says nonmetallic sulfide plus oxygen. You produce a nonmetallic oxide. So your nonmetal is the carbon. Okay, your nonmetal is the beginning part of it here. So some nonmetallic oxide. I don't know what it is yet, so I'm just putting the 2 elements that I need there. Plus SO2. All right, so it says nonmetallic oxide plus SO2. Now, we know from our synthesis and decomp reactions, anytime a nonmetallic oxide is involved, oxidation numbers are involved. So let's figure that out. Let's go over here, a little section for this. For CS2, sulfur has a oxidation number of -2. Because sulfide is usually a -2 ion, right? Or it is a -2 ion. So that gives us a -4 total from sulfur. That means carbon is a +4. So I want carbon to be a +4 on the product side as well. So if carbon is a +4, I know oxygen is always a -2. I would need to have 2 oxygens here. So it would be CO2. That would give me a +4 oxidation number on carbon. And then overall total for oxygen would be a -4. So it's -2 times 2. So we're going to create CO2 plus SO2. All right, let's balance it out. Let's see if we can do that. So I have CS2 plus O2 yields CO2 plus SO2. Let's balance our carbons first, and it looks like that's done. Let's balance our sulfur next. So I have 2 sulfurs here on the reactant side. Let's get 2 on the product side right there. And now I'm going to erase a little bit of this to clean it up a little bit so we don't get too confused with what's going on here. I need to balance oxygen last. So I have 2 oxygens here, 4 oxygens here. That gives me 6 total. So I need to put a 3 here. 1 there if you want it to look like that in there. So you have CS2 plus 3O2 yields CO2 plus 2 SO2. Not too difficult. So if you see a weird combustion reaction, just remember the bottom of your blue cheat sheet has the overflow there. Again, not going to happen too often. Most of your combustion reactions are up here, your traditional variety. Just be aware that other types exist and they're found on the blue cheat sheet. All right, sounds good, guys. See you later.